So in this video, we're going to go over the process for importing data into MATLAB. Although, of course, as a programming language, you do have the capability to do that in what is known as a programmatic fashion, which means just writing code in order to import data from a file. I'm going to show you mostly in this video how to use kind of the GUI in order to do it using what is known as the import data app that's built into both the MATLAB desktop application along with MATLAB Online. What we're going to find is that we're also going to need to utilize MATLAB Drive, which is the cloud-based storage that's associated with your MATLAB account in order to open that data using MATLAB Online. So you'll get an opportunity to learn a little bit more about that if you haven't so far. The way you access it, the URL is just drive.matlab.com, and we'll get to see that a little bit later on. But before we do that, we have to talk about the data type as a variable when we import this data into MATLAB. That we will be using by default. Of course, depending on the type of data, there's multiple data types that you could use, but traditionally we're talking about importing what is known as tabular data. So before we discuss any of this, we need to talk about what tabular data looks like. And if you recall back to lecture 1, particularly the supplemental lecture that I posted, where we talked about these data repositories that are really kind of emerging and driving forward the data revolution as we move towards this idea of data science and big data and artificial intelligence, which of course requires data in order to train these large models in order to exchange this information across end users across the globe. We need a bit of a standardized form in which to store our data, and that is the idea of tabular format or a table data type. And this is really an important concept that generalizes across MATLAB into Python and any of the high-level scripting languages that you're dealing with in order to process data. This would include things like R, of course, as well. So I'm going to cut my video feed. That way you can focus more on the slides and the code that I'll be writing. So let's start off by talking about what exactly is a table. Well, put simply, when you think of a table, just think of a spreadsheet. Think about something that's organized into rows and columns. Well, what are the actual columns? Well, the columns are the actual variables that are being described in the data set. So here you see a visualization that might make it easier on the left, where we have informations about patients. Those patients are defined by an ID number. Of course, they have a last name, they have a sex, they have an age, and so on. So these are all variables that correspond to particular samples or instances or records that we have. And those are going to be stored in the rows. So the rows are just particular samples of the data, and each of those samples is described by variables which are organized in a column type basis. So what are the actual file types utilized for storing these type of tabular data structures? Well, they can be stored, since, again, we're thinking about them as spreadsheets when we, if we want an easy way to kind of wrap our head around it. Of course, any file extension that can be used to store a spreadsheet can be used to store tabular data that we can then import into MATLAB or import it into any high-level scripting language like R or Python or so on. So the most common is a .csv file. That is a comma-separated variable. If you were to actually dig into the information that's stored within that file, not necessarily opening it in Excel, but actually looking at what's going on underneath the hood, what you would find is that each variable for a particular sample or instance, or a row in this case, is going to be delimited, meaning separated by a comma. And that probably is familiar to you, because when you think about how MATLAB actually stores numerical data within a matrix, scalars within a particular row, of course, are separated or delimited by a comma as well. Now, comma, there's nothing special about that. That's just a symbol that we're going to use to recognize that we're moving from within a sample, one variable to another. So it really can be any delimiting character that we choose to use. So just be familiar with the fact that you can have tab delimited files as well, and so on. But of course, the CSV is the most common kind of traditional file format used for storing tabular data. In addition, of course, as kind of the Microsoft Office productivity suite has kind of emerged as the market leader, maybe now you think of spreadsheets as being stored in Excel files instead, .xls, and all the modifications that have been built on top of that to make the spreadsheets more functional and more sophisticated, like a .xlsx and so on. Generally speaking, if you can open it in a spreadsheet, of course, it's organized into rows and columns. That is the format of tabular data, so not surprising that you can import it within a programming environment. So let's talk about MATLAB's import data actual application. And I'm going to change that on the slide here. It should say app. And what I'm trying to point to you here I have a screenshot from the actual desktop version, this is 2021B. When I took this screenshot, I have, don't know which version of MATLAB I have installed now, 2022B. And if you're on the Home tab, you can see that import data still looks kind of the same in that case. And generally speaking, the user interface for MATLAB won't change significantly year over year. So you can expect that it'll always be on this Home tab and have that kind of green arrow to indicate import data. Below is a screenshot from the actual MATLAB online. And if you notice, it looks quite the same. And by clicking that button, that's how you can, through a GUI-based point and click workflow, import data into MATLAB. And we'll go over that. But the one thing that I did want to bring to your attention is, of course, there are built-in functions within MATLAB to kind of automate the import process within your script. If you're not necessarily dealing with data in which you actually want to retain the names of the variables, which are traditionally going to be stored in the top row of a spreadsheet file, you can use read matrix. Just like it sounds, it is optimized in order to just import kind of numerical tabular data where you're not worried about the variable names. But there are automated functions, I should say, within MATLAB that allow you to import data in a programmatic fashion within your code. However, for this video, we're going to focus on the actual import data app. Now, the one thing that I mentioned here, and there's a hyperlink to drive.matlab.com, is when you actually import the data into MATLAB Cloud, of course, you're going to need to have that data uploaded somewhere where the cloud application can find it. And we haven't talked about it much. I think I mentioned it a little bit in some of the older videos I posted, but whenever you're working in MATLAB, you have this current directory, which you can basically view as the place in which MATLAB is looking for any file that you reference only by its name and not its path on the command line. Just think of it as these are the easiest files to access within MATLAB, along with anything else that is on the path at the moment. And that's a little bit beyond the scope that we're talking of now. So, of course, this file here, if you notice, it's living in my locally on my machine in my actual downloads directory. When I'm working with MATLAB Online, it doesn't have direct access to my computer. So I'm going to need to upload the file that I want to import to a dedicated cloud folder that I have, and that is known as your MATLAB drive. So we'll look at that in a minute. So once I have an actual table imported into MATLAB, how do I work with it? Well, if you think about what we said initially, since tabular data is segmented into rows and columns, much like a matrix, really the only difference here is the variables have names associated with them. We can use traditional matrix indexing, which is what I'm showing here at the bottom. However, whenever you're dealing with tabular type data in MATLAB or Python, it's going to be preferable to use what is known as the dot notation. So when we have a table defined as a variable within our workspace in MATLAB, if I place a dot afterwards, I can refer to particular variables within MATLAB using the variable name that's assigned to it. And I think I have a, let me see, yeah, I do. I pulled in already the actual data that we're going to be working with in the example. It is building permit information from the city of San Antonio. If you look in my workspace here, it is stored as a table data type, and the name of that variable is permits issued. So notice if I type permits issued, and then I type the dot, and then I tab out, I can see all of the different variable names that are stored within my actual data table here. And if I double click on my workspace, of course, I can see those names as well. One thing that I should have mentioned, I had it on the slides, but I didn't talk about it at the time, is typically in a perfect world, each of your instances are going to be complete. And what that means is that if I look at a particular row within my table, all of the variables are going to be populated. There's not going to be any missing data. However, in the real world, of course, you will have missing data very routinely. Here you can see, if I focus in on row 3, column 7, or for instance 3, the x coordinate, I see NaN, not a number. And that is traditionally kind of an entry that's used within a table to denote missing data. So that's a really, really important concept, that NaN, or not a number, denotes missing data. And you can kind of, in the data import and cleaning workflow, utilize the fact that that is used as a placeholder in order to automate your data importing and cleaning. So here we see how we can use the dot notation on a table in order to extract a particular variable, just to show you how that works. Again, I have permits issued. If I do permits issued dot address, you'll notice that I get a lot of information there, but my actual answer here, which of course is where all of that information is stored as a variable, Notice that it is a column vector. It has a bunch of rows. It has one column. So it is an array or vector. It has the same number of rows as the entire number of rows in the table, but it is a string array. And the reason that it's a string array is if you notice, I extracted the address variable here. And the address variable is an array of strings corresponding to the address for which the building permit was issued. So just to show you really quick how you could use traditional indexing, matrix type indexing. So if I go to permits issued and I type in 1, 2, it will work exactly as you would think. It will go to sample 1 or instance 1 in column 2. So that is going to be, let's kind of zoom out a little bit, the permit identifier for, let's go to something that's easier to see. Let's go to address, so 1, 5. This would be the address of the first entry within my data file. So if I execute that, not surprisingly, I see the address there. So going back to our slides, let's look at some different example problems. So what we want to do is consider the file permits issued.csv, which is stored in our example data folder of the course module. And if you're like, oh, I haven't seen that yet, that is because I've just added this this evening. So there is example data. The first thing you want to do is actually download this permits issued file. And then we're going to answer some questions about it. Particularly, we're going to import the file using the import data feature, change the name of our import variable to permit data, and then answer some questions about what is going on. So what I'm going to do is actually for those of you that are using MATLAB application, I'll show you how to do it here first. So I will clear all just so it's out of my workspace. What you want to do is left click on the import data and then navigate to wherever the file you downloaded is stored. Mine is in my downloads folder. Here is my permits issued. I double click on that. And if you notice, I want to change the name to permit data. Now you might wonder where you actually go about doing that. Here, well, a couple things I wanted to point out to you is in the output type drop-down menu here, you can actually change how you're importing your data. I want to import it as a table, but if I don't want those variable names, I could change this to a different format. But for our purposes now, this is kind of what you would call multi-type tabular data. And what I mean by that is we have some dates, we have some just double numerical values, we have some strings, and so on. And if I want to change the actual name of what I'm importing, and I want to change it to permits data, the way that I do it in the MATLAB desktop version is to change this top row, this top field. If you kind of hover over that, you see that that is where you edit the variable name. And then once you've done that, just left click on import selection. And this is going to take a while because it's a pretty big file. But we get a success message that we've imported permits data. And we see that it is, what is that actually? 216210. So 216,210 rows. So that's how many different samples or instances of permits that we have recorded. And notice that each record of a permit is described by 16 variables. And we see some of the names here on top. And I can show you, I don't think I actually still have the website open, but I will post a link on our actual module for this week, kind of showing you the City of San Antonio site where I downloaded this. And for all of the data files that are on the City of San Antonio site, I shouldn't say all of them, but at least the majority of them, and just the majority of data files that are posted across the internet, you have what is known as a data dictionary. And a data dictionary is very valuable for providing additional metadata describing what each of those variables means, and just kind of like a README file associated with your actual the actual data that you imported. So within the resulting table, how many variables, which of course are the columns, are present, and how many samples or rows are present. So all that we need to do once we have this in the workspace is look at the size of our actual table here. Notice again, it is 216,210 rows. Each row is an instance or a sample using this notation here. So that answer would be 216,000 and change. How many variables or columns are present? And of course, looking here, that is 16. For those of you that are going down the AI route or machine learning route, oftentimes you will call the columns your actual features. So using the class function and the dot notation introduced within this module, determine the data type of the date submitted variable. So first and foremost, let's make sure that date submitted is a variable. I can do that two ways. I can double click on my workspace and just note and see that date submitted is actually the 9th column within this table. If I didn't want to do that, remember that I can just type the name of my table variable. I can tab to autocomplete. I can type dot. And if I tab out, I can see all the variables that are available. So notice that date submitted is one of those. I don't want to just necessarily execute this command right here, because what it will do is it will extract all the samples of date submitted. So I'm going to get basically a 216,000 column array of whatever data type date submitted is. What I want to use is the class function in order to see what type of data that is. And if you notice, this is a particular data type called date time. And as we talked about a little bit earlier in the course, when we talked about all the data types associated with MATLAB or in general programming languages, what we see is that as languages become more sophisticated, as they become higher level languages, oftentimes they have customized data types for things that could otherwise be stored using prior data types. Like, for example, I could store the years. Years are just a bunch of numbers, right? So I could store them using some type of numerical data type. However, since there are probably specific operations that I routinely want to perform on dates that are stored within my software, it's going to be nice to define a custom data type for them, because then I can define specific operations that I can do to the date time type. But that is the answer here for what the data type of the date submitted variable. It is a date time type. And then what I want to do is download the permit visualization starter script.m file from the course website. Just like we now have sample data, we also have a subdirectory called, I should say example data. We have a subdirectory called example code. So you can either download that, or just, once it eventually pulls up, copy the text from that. Sorry. Anyways, we're not going to wait on it. We'll go back here because I've already downloaded it. Here is the actual code here. And if you notice what is going on, so clearly I was supposed to not call this permits data, but permit data. So what I can just do is say permit data equals permits data. That way I make a copy of it. And then I'm going to clear my permits data, the variable that I didn't need. And now what we want to do once we have this particular code downloaded is go through it and say, what do you think the code is doing? How could the code be improved? Do we notice any patterns within the underlying data? And identify at least a few concepts that we've spoken of in class. And one thing I noted here is we probably haven't seen a lot of these concepts in the script yet in class. But if it's good code, right, then all of our identifiers, variable names and so on, in addition to being valid syntax, they should be meaningful. So if you notice what this is doing, I'm defining a variable unique dates, easy for me to set, and I'm assigning that variable the output of the function unique. How do I know that this is a function unique? Well, I'm passing something in inside parentheses. And anytime I pass something in inside parentheses, that thing that what I'm passing in is a parameter or argument typically going into my function. So if I wanted to see what the actual unique function did, then right on the command line, I could just utilize the help function in order to get a quick description. And just scrolling up here, we see that what the unique function does is for the array A returns the same values as an A, but with no repetitions. And I'm actually going to sort my resorts as well. So what am I basically finding the unique values of? Well, permit data is the actual name, of course, of my table, and I'm extracting the date submitted variable. So really what I'm doing here, if I just kind of read the syntax, is I'm finding all of the unique dates for which permits were submitted within this file. What's one way that I could improve this? Well, in terms of that line of code, this is a pretty good variable name. It makes sense with respect to what we think the code is doing. However, I could add a comment to it if I wanted and say, hey, basically find all of the unique dates for which a permit was issued. And then here I have this keyword for, and if we notice the IDE is kind of matching it to a keyword end. This is something we're going to cover at the end of this week, which is the idea of conditional execution structures within MATLAB. And we'll see that what a for loop is good at doing is if I have a code block that I want to repeat for a fixed number of times, the for loop is the appropriate structure in order to do that with. So anything inside this loop is going to be executed a fixed number of times. In this case, since the looping variable is going from 1 to, now what is length here? Well, that's another function that is built into MATLAB as well. And what are we passing in? Well, we're passing in this unique dates identifier that we defined on the prior line. So if you think about what we hypothesized that this was doing, finding all the unique dates where building permits were issued, the length of that is just going to tell me how many days building permits were actually issued. And then here I have permits per day. That is a user-defined variable that's camel cased here, much like unique dates. I have parentheses K, so it's kind of like I'm likely defining an array here, and I'm going to, each time the loop runs, define a new entry into my array. So what am I doing? Well, I'm summing, sum being a built-in function into MATLAB, all of the permits that are submitted on each unique date. So if you think about what we have here, we have 216,000 different permit records. And what it looks like this code is doing, and I know we haven't talked about the actual function of a lot of these functions yet, or even conditional execution, but we're just extracting all of the dates that permits were submitted, and we're summing how many happen each day, and then we're going to make some sort of line graph or visualization plot. So let's actually just run this and see if it will run. So remember that if I'm in the editor, I can just click on run and see what happens here. And not surprisingly, what you see is for the given range of time for which this actual file contains permit data, I have a plot of how many permits were issued each day. And if you look at this kind of time series here, and time series is the appropriate word for it because it's data that's stored over a variable index of time. If I zoom in on it, it's probably not surprising to you to see that this thing has different levels of seasonality. It has seasonality over the course of a calendar year. And if we just zoom in on one of these individual peaks, if we were to go back and look at the calendar, we're just counting here. We have 1, 2, 3, 4, 5. Before that, it goes to 0. After that, it goes to 0. What we're likely seeing here is the seasonality within a week, where permits are filed Monday through Friday, but not on the actual weekends. So not too surprising there. So how do you do this if you're using MATLAB Online? Well, the first thing you want to do is go to drive.matlab.com and actually upload that data file that you downloaded. So I'm going to go and actually grab this file, permits issued, and click upload. It's going to take a while, right? Because it's a big file. I probably should have done this before I started recording. But then in MATLAB Online, what you want to do, and kind of going and showing you what I meant by you don't necessarily have to download this M file. If you just copy all of this text here, and then in your MATLAB Online, just say you want to open a new script and then paste it there. You can save it yourself as, and what was the name of that file? I just want to make sure that I call it the right thing. Permit visualization starter script. I can save that. And it might tell me that, hey, I've already saved this because I named it the same thing when I taught this class over the summer. So that's why it's telling me that I'm replacing something. But there we have the file that we're going to need in order to do the visualization example that I just showed. And then looking, MATLAB is eventually going to be able to upload all of this data here. We're getting close. So while we wait for it, I'm going to make this change that I had talked about. That is import data application. Typically, MATLAB around the time, probably about 3 to 4 years ago, they started to market a lot of integrated applications that allowed users to do things not necessarily on the command line, but more in a GUI point and click type fashion. If you're into AI, they have a really nice various different actual applications for machine learning that you might want to check out if you have the desktop version. That's one of the hard things. If you don't have the desktop version, if you're just using MATLAB Online, you're kind of limited to whatever apps they have integrated here. But they do have some cool ones that hopefully we'll get some time to look at in the course. But what I want to do is, now that this is in MATLAB Drive, I can go down, and your file tree won't have as many files here. So you'll be able to see permits issue.csv. You won't have nearly as many files, but hopefully it's there. The reason that it's there is you pulled it using the MATLAB Drive app from your local computer to your cloud account. By default, your working directory within MATLAB Online is set to your MATLAB Drive account. What you want to do is left click on import data now, and then you will go to permitsissued.csv, click open, and that will take a little bit of time as well, where it's a pretty big file here. But here you can actually specify the type of data, the data type that you want to use to import it. Leave that as tables. And then when you're doing this application, remember that you want the name of the actual variable that you're importing to be permit data. You change that in the name here. So if you just do permit data, import selection, and wait for it to come into your workspace here. And then if you run this script, which you can do by going to the editor tab and typing run, or just typing the name of the script on your command line, you should get that same plot that demonstrates those seasonality trends that we did when we used it in the MATLAB app. So how could you improve this? Well, you could add comments, you could add some labels to your axes in order to make the actual visualization more useful, and so on. So hopefully this video was useful for you. The main things you want to take away are that table data types know what the meaning of the rows and the columns are. The columns are variables. The rows are actual samples of data. Know how to go through the import process using the MATLAB import data app, and I don't think I would ask you anything else. Anything that I'm going to ask you about that on a test will largely be reflected on the actual homework review that we're going to do this week. So for the next video, we're going to look at archive files just to get this up as soon as possible. As I mentioned in the intro video this week, that is going to be a legacy video along with the module 3 video as well. So both those were recorded over the summer. So if I say anything and you're like, hey, what is he talking about for this particular thing, just note that this video you're watching now is one that was recorded this semester, and then these other two that you're going to be watching are from over the summer. And that's just so I can spend more time kind of making sure that I get all your stuff graded before the exam, and record the solutions video, because I did change the exam 1 review somewhat, and getting that additional lab up this week. So if you have any questions, feel free to reach out, and if not, we'll talk to you soon.